Good evening everyone and welcome to another lecture of engineering mechanics, and this is lecture number 21 of kinetics of rigid bodies. So beta, we have already completed kinetics of particles. I told you that in case of particles we can't have rotation or general motion. So we can only have translational motion, and we have seen in case of translational motion how we can solve the problems. Now we are going to see kinetics of rigid bodies. But before we start with kinetics of rigid bodies, let's solve the problem that I gave you in the last class as an assignment. So this was the question, a very interesting question. A bullet of mass 20 grams fired horizontally with a velocity of 200 meter per second hits a wooden block of mass 500 gram resting on a horizontal plane as shown in figure, and the bullet remains embedded in the block after the impact. So what is happening right now? This bullet is moving with a velocity of 200 meter per second and this block is at rest. Now when the bullet hits this block, it remains embedded in the block, means it gets stuck in the block. If the coefficient of friction between the surfaces in contact is 0.3, distance the block will move before coming to rest is. So understand what is happening. When we'll hit this block with the bullet, after hitting this block, the bullet will get stuck. So both these bodies will now move together. Okay, both these bodies will now move together like this. They will move together and let's say they reach here, the bullet and the block. Okay, now understand. We know that they are saying before coming to rest what will be the velocity. Okay, so we know that the velocity at this point is 0, right? But what is the velocity at this point? Do you understand what I am saying? You will say, sir, the velocity will be 200 meter per second. No, it is the velocity of the bullet. But when the bullet will hit this block, then the velocity of the block and bullet combined will change. So we have to calculate that velocity when the bullet will hit the block and they will start moving together. With what initial velocity they will start moving? See, right now the bullet is moving at 200 meter per second and the block is at rest. But when the bullet and block will become a single body, when the bullet will hit the block and they become a single body, then the velocity will change. It will neither be 200 nor be 0. It will be between 200 and 0, some value. With that initial velocity, both will move. But due to friction, the velocity will start decreasing and ultimately the block will come to rest. So we have to calculate what will be this distance. But in order to calculate this distance, we need this initial velocity. So how do you calculate this initial velocity? Here comes a very interesting concept. We know that the impulse given to a body, summation of F into dt changes the momentum, right? If there is an external force acting on the body for a very short period of time, then the impulse of that force will change the momentum. So the velocity of the body will change from u to v. But what if this net force is 0? It means the change in momentum will be 0, right? The change in momentum will be 0, means the momentum will be conserved. So here comes the concept of conservation of momentum. Whenever the external force acting on a system of bodies is 0, then that system will have conservation of momentum, means the momentum of that system will remain constant. Understand what is happening. See, when this bullet hits the block, the bullet will apply some force on the block and the block will apply equal and opposite force on the bullet. If I consider the bullet alone, there is external force acting on the bullet. So the momentum of the bullet is changing. If I consider the block alone, there is external force acting on the block. So momentum of block is also changing. But what if I consider bullet and block together? In that case, the force acting on the bullet and the block, they will cancel each other, right? The net force will become 0. Whatever force the bullet is applying on the block, equal and opposite force block is applying on the bullet. So net force is 0. If I consider both of this as a single body, as a single system. So this entire system, for this entire system, the momentum will remain conserved. So what we can do is, we can apply conservation of momentum. Okay. Initial momentum of the system consisting of two bodies, let's say m1u1 plus m2u2, and final momentum is, let's say, m1v1 plus m2v2. What is m1 and m2? They are the mass of the first and second body. What is u1 and u2? Initial velocity of the first and second body. What is v1 and v2? Final velocity of the first and second body. Now understand, the first body is, let's say, the bullet. So bullet has a mass of 20 grams. And the initial velocity of the bullet is 200 meter per second. Now the second body is the block, which has a mass of 500 grams. But the initial velocity of the block is 0. The block was at rest initially, right? Now finally both the bullet and block becomes a single body, means their velocity will become same. So I can say that v1 and v2 both is u. I am considering this velocity to be u. So it will become 20 plus 500, m1 plus m2, v1 and v2 is equal. So it will come out, okay, common into u. So from here you will get the initial velocity with which the block and bullet will move together. 20 into 200 divided by 520, I am getting 7.69 meter per second. So this is the velocity with which both the bullet and the block will start moving together. Okay. Now both are moving together with the initial velocity of 7.69 meter per second. But due to friction, their velocity will start decreasing. Understand, when the bullet and the block are moving together, what are the forces acting on them? Bullet and block both are moving together with some initial velocity. Okay. Now the force will be weight of this. Okay. Then there will be normal force, and both are moving towards right. So the friction force will be towards left. Okay. What is the weight? See, their total mass is 520 gram, means 0.52 kg, and let's say g is equal to 10. So it will become 5.2 Newton. Okay, weight will be 5.2 Newton. Let's say this is N1, and what is the coefficient of friction? 0.3. So this is 0.3 N1. Now understand, in y direction there is no motion. In y direction there is no motion. So N1 will be 5.2 Newton. Okay. Now in x direction, in the direction of motion, what is the net force? It is minus 0.3 N1. Why minus sign? Because the motion is happening towards right and the friction is opposite, towards left. That is why the negative force. Okay. So it will become minus 15.6 Newton. Okay. So we have the force acting in the direction of motion. Now we can apply work energy. Now we can apply work energy. Work done equals to change in kinetic energy. Okay, so from 7.69 meter per second to 0 velocity, what is the work done? Net force is minus 15.6 into, let's say this distance is x, which we are calculating. Total mass is 0.52 kg. Okay. Final velocity is 0. Initial velocity with which they are moving is 7.69. So from here you will get the value of x. And x is 0.98 meter, almost 1 meter. Okay. So this is the distance by which the block will move before coming to rest. I hope you understood this question. So you will come across this type of questions a lot. In fact, there was a question like this, similar to this, in gate also, where two blocks were hitting each other. So whenever there is a question of impact between two bodies, you can apply conservation of momentum, because whenever the impact will happen, the net force between the bodies will be 0, because whatever force the first body will apply on the second body will apply equal and opposite force on the first body. So net force will become 0. Okay, chalo. So let's move on to today's lecture. Now today we are starting the concept of kinetics of rigid bodies, where we will learn how to solve problems of kinetics of rigid bodies using D'Alembert's method. And here, when we will apply D'Alembert's method, we will need to know the concept of mass moment of inertia also. Okay, chalo. So beta, we have seen the translation motion in kinetics of particles, but here we will see all three types of motion, because rigid bodies can have translation, rigid bodies can have rotation, and rigid bodies can also have general motion. Okay, so we will understand all these three concepts in case of kinetics of rigid bodies. So beta, let's first understand how to apply D'Alembert's method in case of translation motion. See, understand this. When we were studying about the particles, I told you that even if you apply Newton's second law instead of D'Alembert's, what is the difference between Newton's second law and D'Alembert's? See, Newton's second law says summation of F equal to ma. But D'Alembert says that you apply an opposite force ma on the body and you can assume the body to be in equilibrium. Okay. Now, I told you that in case of particles, Newton's second law, D'Alembert, both will be same. But in case of rigid bodies, it becomes a little different. How? Understand that. See, let's say the body is subjected to different forces. Let's say the body is subjected to different forces. Okay, and this is the center of gravity. Okay, if you are applying only summation of fx equals to 0, summation of fy equal to 0 types equations, if you are applying that, then though you don't have to worry. But if you apply summation of m equal to 0, then there will be a problem. Understand why. The net moment of these forces will not be equal to 0, because you will have to apply another force, which is the D'Alembert force. If you apply the D'Alembert force, then you can apply this equation, summation of m equal to 0. Otherwise, if you apply summation of m equals to 0 without considering the D'Alembert force, what is D'Alembert force, beta? D'Alembert force is the force acting opposite to the direction of motion. The body is moving right side, so D'Alembert force will be left side. ma. It is also known as inertia force. Without considering inertia force, we can't apply summation of m equal to 0. When you apply the initial inertia force, then you assume that the body becomes static. So in that case, you can use any equilibrium equation, summation of fx equals to 0, summation of fy equal to 0, and summation of m equal to 0. But without applying this inertia force, you can't use summation of m equal to 0. In case of particles, we were not taking moment in any problem because particles don't have size, na? We were not considering the size, we were not considering the distance. So that's why we never used the moment equation. So there was no problem. But in some cases of translation motion, you will have to use summation of m equal to 0. So there you will have to use this D'Alembert concept. Apply the inertia force ma on center of gravity opposite to A, and then you can apply summation of m equal to 0. Let's solve a problem, okay, then you will understand. Let's say this is a problem. A force of P equal to 300 Newton is applied to 60 kg cart as shown in figure. Mass center of the cart is at G. Neglecting friction at the wheels, the normal reaction at the wheels at B is. They are asking you to find normal reaction at B. Now understand. If you draw the free body diagram, how it will look. Now understand, first of all, see, by looking at the question, you should understand that this is a problem of kinetics, not statics. A lot of people assume this is a problem of statics. How they solve this problem? They just consider the forces in y direction and then they do summation of Fy equal to 0 and they try to calculate. See, this is not a problem of statics. Understand why. If you apply a force like this and there is no friction on the wheels, who will stop this cart? Who will stop this body? No one can stop, na? If there was friction here, then it would have stopped this body. But if there is no friction and if you apply a force like this, due to the horizontal component, the body will start moving. So it is not a question of statics, it is a question of kinetics, okay? Now, if you draw the free body diagram, you will get these forces. What is the weight? 600 Newton, okay? Now, they are saying normal reaction at the wheels, okay? Normal reaction at the wheels. See, there are two wheels here, there are two wheels here. So we are not going to consider the wheels separately. Both the wheels have, let's say, the total reaction Na, both wheels combined. Here both wheels combined reaction Na, here both wheels combined reaction Nb. Okay? Now, understand. In order to calculate Nb, what you are going to do? What you are going to do? First of all, you will resolve this force. है ना? So this will be P sin 30. This will be P cos 30. Okay. Now understand. In order to solve this problem, you will try to apply summation of Fy equal to 0. Right? You will try to apply summation of Fy equal to 0. See, this body will start moving in this direction. This body will start moving in this direction with an acceleration A. There will be no motion in y direction. So summation of Fy will be 0. But that is not going to give you the value of this reaction. Why? Because there is another reaction Na. Okay. So you will not get Nb directly from summation of Fy equal to 0. Can you apply summation of Fx equals to 0? Summation of Fx is not 0. Summation of Fx is not 0. Summation of Fx will be equal to Ma. Summation of Fx will be equal to ma. Okay. So beta, what is the net force in x direction? P cos 30, right? Net force in the x direction is P cos 30. Mass is 60 kg. P is 300 Newton. So what is the value of A? P is 300 Newton, right? This will be 150, right? 300 cos 60 is 150 divided by 60. So A is 2.5 meter per second square. Sir, why are you calculating A? We don't need A. We will need A. Why? Understand. See, in order to calculate NB, you will have to take moment. Where will you take moment? You will take moment at A. If you take moment at A, moment of NA will become 0 and you will get NB. But you can't take moment at point A without considering the inertia force. Why? See, it's a concept of Newton. Newton said that if we are taking moment at a point which is in motion, which is not fixed, or which is not the center of gravity, either the point should be fixed or the point should be center of gravity, then you can take moment without considering the inertia force. But if you are taking moment at a point which is moving, this body, if the body moves, point A will move, right? So if you are taking moment about a moving point, then you will have to consider the moment of inertia force also. Then only the net moment will be 0. If you are taking moment at point G, then you don't need to worry about the inertia force. If you are taking moment about a point which is fixed, then you don't need to consider the inertia force. So I hope you understand this. Whenever you are taking moment, you have to consider the inertia force if you are taking moment about a moving point. If you take moment about a fixed point or center of gravity, you don't need to consider the inertia force. Fixed point or center of gravity, no need to consider inertia force. But if you want to take moment about any other point which is moving, you have to consider inertia force. So I want to take moment about point A, right? I want to take moment about point A. So A is moving point and it is not center of gravity. Center of gravity is also moving, but we can take moment about center of gravity without considering inertia force. Okay, but A is not center of gravity and it is moving. So we will have to consider the inertia force. What will be the inertia force, beta? Inertia force will be M into A. Now you can take moment about point A. Now it is okay. Okay. So if I take moment about point A, I will get the moment of NB anti-clockwise. NB multiplied by 0.5. Okay. I will get the moment of 600 clockwise minus 600 multiplied by. Let me write it from here, okay? Because it will be a very long equation. 600 multiplied by 0.3. Okay. Moment of this MA will also be clockwise, right? So minus MA multiplied by this height is how much? 0.3. Okay, A point is here. I am taking moment here. Okay. Then moment of P sine 30 will also be clockwise. So 300 sine 30. Clockwise moments are negative, anti-clockwise moments are positive. Okay. It's not a general rule. I have considered anti-clockwise positive, clockwise negative. 300 sine 30 multiplied by 0.08. Now P cos 30, this moment will be anti-clockwise. So we will consider it negative. So 300 cos 30 multiplied by 0.4. And this will be equal to 0. So this is the equation of the moment. Now in this equation there is only one unknown, which is NB. So we will directly get the value of NB. Okay, M is equal to 60 and A we have calculated 2.5. Okay, so put all the values here. I am getting 266.15 Newton. I don't know about you guys. I hope you also have got the value 266.15 Newton. Okay. So understand what I am saying. If you want to just apply this equation, you don't need to worry about the D'Alembert force. But if you want to apply the moment equation about a point which is not center of gravity and which is moving, then you will have to apply D'Alembert force. Otherwise, your moment equation will be wrong. Okay. Let's consider another question. This is a very interesting question. Another very interesting question. For what acceleration A of the frame will the uniform slender rod maintain the orientation shown in figure? Something like this question came in GATE 2023. I think in XC paper or ME paper. I don't remember exactly. ME or XC, but in GATE 2023 there was a question similar to this. Okay, understand, for what acceleration A of the frame will the uniform slender rod maintain the orientation shown in figure? Okay, neglect friction and mass of the small rollers. So understand, this is a frame which is moving in X direction with acceleration A, and we have a rod which is at an angle 30 degree right now. Have you experienced this? If you suddenly accelerate a vehicle, or if you suddenly apply brakes, applying brakes means de-accelerate. If you suddenly accelerate or de-accelerate, you slip with respect to the body, right? For example, if you are sitting in a car, let's say your father is driving that car, suddenly someone comes in front of him and he applies brake. What happens? There is a huge de-acceleration. A value is very large. Now you slip, right? It happens. Or if he suddenly accelerates also, then also this thing will happen. You will slip backwards, right? So that is what is going to happen here. If the value of A is very large, then this body will slip. But if the acceleration is small enough, if the acceleration has a particular value, then this will not slip. It will remain at 30 degree only. Okay. So we have to find that acceleration at which it is not going to slip. Now, understand, this is a very simple question. Although it looks very difficult, it's a very simple question. If it is not slipping with respect to frame, it means it will move just like frame. Means it will be in translation motion, right? If this rod is not slipping with respect to frame, it will be in translation motion like this. Let's say this is point A, this is point B, this is the center of gravity G. So this rod is under acceleration A, just like the frame, because it is not slipping. So it will also move like the frame. Now, you have to find the value of A. How you can find it? Understand. Okay. Draw the free body diagram. So the weight will be acting at point G. What will be the weight? It will be mg. There will be normal reaction at A and B. There will be no friction. They have told that neglect the friction of the small rollers. So this is NA, this is NB. Now let me tell you how you can solve this problem. See, Na and Nb, they are unknowns and I don't want to find them. So if I take moment at a point, where Na and Nb both are intersecting, then I will not have to consider Na and Nb, right? I have to take moment at a point where Na and Nb both are intersecting. So I will not have to consider them. But if I want to take moment, I will have to apply D'Alembert force. So let's apply D'Alembert force. Now it is moving right side with an acceleration a. So D'Alembert force will be left side, ma. Now you are free to take moment. Okay, where you will take moment? I have to take moment at a point at which moment of Na and Nb both will become 0. So if I extend this like this and if I extend it like this, now this is the point. Let me call this point as point C. So if I take moment at point C, moment of Na and Nb both will be 0, na? So I will get the moment of Ma, I will get the moment of Mg. Yes, simple question. So take moment at point C. Okay. Now understand, if I take moment at point C, moment of Na and Nb gone. Moment of Ma will be clockwise and it will be Ma into this distance will be L by 2, right? X by 2. Let's say X by 2. This is some distance X by 2 and this distance will also, let's say this distance is X. Okay. Let me do this. Let's say this length is L. So this will be L by 2 from here to here, and from here to here this will be L by 2. So what is this distance? This angle is 30 degree, na? This angle is 30 degree. So look at this, L by 2 and 30. So what will be this distance? Distance of Ma from point C. This will be L by 2 sine 30, right? L by 2 sine 30. So Ma into L by 2 sine 30. Now moment of Mg will be opposite, minus Mg into, now we have to find the distance of Mg from C. So we have to consider this distance. Now look at this triangle, L by 2 and this angle is 30. So what will be this distance? Distance of Mg, L by 2 cos 30. Now M cancelled, L by 2 cancelled. I will get A equal to G cos 30 by sin 30. Okay. What will be the value? Cot 30 root 3. The value of A is G root 3. At this acceleration, it will just move like the frame. It will not slip. It will move like a frame, like the frame. Translation. But if your acceleration is greater than this, then it will slip. Okay. Chalo. So these type of problems of translation where you have to take moment, then you will have to apply this D'Alembert's method. Okay, you will have to apply the inertia force, Ma. Okay. Now this was the case of translation motion. But what if there is rotation or general motion? Let's say we have a body like this, okay, which is subjected to different forces. This is the center of gravity. Okay. It can be either in general motion, it can also be in rotation. In both cases, the method is applicable. Now understand. First of all, you will have to know the direction of alpha, AT and AN. Right now, let's assume their directions. Let's say the direction of alpha is like this. Let's say the direction of AT is this and direction of AN is this. It will depend upon the question. Okay, you can find the direction of alpha, AT and AN. What is AT and AN? Alpha is the angular acceleration, right? Tangential acceleration is alpha into r and normal acceleration is omega square into r. Remember? I hope you guys remember. We have studied this in kinematics of rigid bodies. AT is the tangential acceleration, which is alpha into r, where r is the distance of center of gravity. R is what? R is the distance of center of gravity, because we are calculating the AT and AN of center of gravity. So distance of center of gravity from center of rotation. Okay, r is the distance of center of gravity from center of rotation. So AT and AN are alpha into r and omega square into r. So you need to know these directions. Now comes the Newton's second law. What is Newton's second law? According to Newton's second law, summation of Ft will be equal to MAT. Summation of Fn equal to MAN. Now this equation you have already used in translation motion, but there was only one acceleration. Here there are two accelerations, AT and AN. So summation of Ft will be equal to MAT, summation of Fn equals to MAN. What is summation of Ft? It is the net force in the direction of AT. What is summation of Fn? It is the net force in the direction of AN. Okay. Now there is the third equation, which is the equation of moment. Summation of m about point G will be equal to Ig into alpha, where I is what? Ig is what? Ig is mass moment of inertia of the body about G. So this is a different equation. You have not used this equation in case of translation. Okay. Summation of m about point G will be equal to Ig into alpha. Ig is the mass moment of inertia of the body about point G. Sir, here you are not considering the inertia forces. You are taking moment, you are not considering inertia forces, because we are not taking moment about a point which is moving. We can take this moment about center of gravity. We can also take the moment about a fixed point. Okay, we can use this equation also, where O is a fixed point, or a point where the velocity is 0. Okay, so the moment equation can be taken about center of gravity, it can also be taken about a fixed point. But if you take this moment about any other point, if you want to apply this equation about any other point, then you will have to apply inertia forces. Here there will be two inertia forces, MAT, MAN. Okay, so that is why instead of applying MAT, MAN, just take moment about G or O, where G is the center of gravity, O is the fixed point. So this is how you can apply the D'Alembert's method, or it is not actually D'Alembert's method, it is Newton's second law in case of rotation and general motion. Let's solve some problems, you will understand. But before getting into the problems, we need to first understand mass moment of inertia. What is mass moment of inertia, beta? If you don't know about these simple concepts, now we have started a new initiative. We have this new YouTube series called GATE Foundation Batch, where we are making videos on these small concepts which you have studied in school but you might have forgotten. You have studied this mass moment of inertia, area moment of inertia, radius of gyration. You have studied all these things, but in your school time, so some of you might have forgotten. If you want to revise them, then you can start this playlist. Okay, this playlist is recently started. Okay, so you can go through this playlist once it is completely done, and you will be able to study all these small concepts, revise all these small concepts. Okay, so what exactly is mass moment of inertia? See, when you consider a body which is rotating about a particular axis, let's say, then the mass moment of inertia is how the mass of this body is distributed from this axis. If the mass is close to this axis, let's say if the body is like this, the entire mass is close to this axis, mass moment of inertia will be less. And if the mass is away from this axis, like in this case, the mass moment of inertia will be more. What is the significance of mass moment of inertia? Understand, what is the significance of mass moment of inertia? Let's look at this equation. Summation of m equals to I alpha. Let's say I am trying to rotate a body by applying moment. I am trying to rotate a body by applying moment. Okay. If the mass moment of inertia is more, alpha will be less, and if the mass moment of inertia is less, alpha will be more. So you can say that mass moment of inertia is actually resistance to rotation. Means the body doesn't want to rotate. If the mass moment of inertia is very large, the body doesn't want to rotate. If you want to rotate it, you will have to apply large moment. But if the mass moment of inertia is very small, if the entire mass is very close to this axis, then you can easily rotate it. So we can say that mass moment of inertia is the resistance to rotation. Okay. Now you have to remember the formula of mass moment of inertia in different cases. Okay. So the first case is the case of a slender rod. Slender rod means what? It's a rod whose length is very greater than the cross section. Okay, larger, very large compared to the cross section. Okay, for example, this is a slender body. Can you see that the length is very large compared to the cross section? Let's say there are 3 points. This is point A, this is point B, this is point G. G is the center of gravity, A and B are the end points. So if you consider the mass moment of inertia about an axis passing through center of gravity, it is given by ml square by 12. Length is L, mass is m. So ml square by 12. But if you consider mass moment of inertia about an axis passing through the ends, passing through A or passing through B, then the equation of mass moment of inertia is given by ml square by 3. Okay, you have to remember both these equations. Ig equals to ml square by 12, mass moment of inertia about center of gravity, and mass moment of inertia about the ends, ml square by 3 for slender rod. Now, in case of thin disc, a disc which is very thin, mass moment of inertia about the center of gravity is given by mr square by 2. Okay. In case of cylinder also, mass moment of inertia is same, mr square by 2. You have to remember all these formula. Okay. In case of sphere, mass moment of inertia 2 by 5 mr square. Okay. So usually you get questions from these bodies only. Okay. Slender rod, thin disc, cylinder and sphere. Let's solve a few problems, then you will understand the concept. So before that, let's revise another concept, which is the radius of gyration. What is radius of gyration? Let's say that this is a body. Right now its particles are distributed, means they are not concentrated about an axis. Let's say I want to find moment of inertia about this axis, but right now the mass is not at a particular distance. Every particle is at a different distance. What if this entire mass is concentrated into a very thin strip? The entire mass of the body M is concentrated into a very thin strip. So now I can assume that all the particles of the body are at the same distance from this axis. I don't know, buddy. I don't remember you from your name. I'm really sorry. So I can assume that all these particles are at the same distance from this axis. Let's say that distance is k. So this k is known as radius of gyration, and if you have radius of gyration, then I will be equal to mk square. Why I am telling you this? Because in some questions they give you the radius of gyration. In that case you will not apply all these formula. In that case your I will be mk square, mass into distance square. Okay, chalo. Let's solve this first problem. This is an MSQ question. Okay, MSQ question. A slender rod of mass 10 kg and length 4 meter is rotating clockwise with angular velocity of omega equals to 5 radian per second at the instant shown in figure. Which one or more of the following statements is or are correct at this instant? See what they are saying. A slender rod is rotating about this hinge. So it's a question of pure rotational motion, and now you need to find out angular acceleration, horizontal reaction and vertical reaction at the hinge. First thing that you need to do is you need to draw two diagrams. The first diagram let's say this is point O and this is point G. The first diagram will be the diagram of acceleration. Here you will mention the directions of acceleration. Okay. Now what will be the direction of alpha? See, this rod is moving like this clockwise, na? Alpha will be clockwise here. What will be the direction of AN? Normal acceleration. If you remember, normal acceleration is always towards the center of rotation. Normal acceleration is always towards the center of rotation. So AN will be this. What will be the direction of AT? AT is always perpendicular to AN and it is moving clockwise. So AT will be this. So the first diagram will show the directions of alpha, AT and AN, because you have to consider the forces in these directions. Now the second diagram will be the free body diagrams. So here you apply the forces. So this body will be subjected to weight. G is equal to 10, M is equal to 10. So W will be 100 mg. And it will be subjected to horizontal and vertical reactions, right? Let's say horizontal reaction is Rx, vertical reaction is Ry. So they are asking you to find alpha, Rx and Ry. Okay, let's solve this. The first thing we will calculate is the value of alpha. How we can find alpha? See, I told you that in order to find alpha, we can apply this summation of m equal to I alpha. But we can take moment about G, or we can take moment about a fixed point which is not moving. If I take moment about G, I will have to take moment of Ry. Moment of 100 will be 0, moment of Rx will be 0. But I will have to take moment of Ry, and right now I don't know Ry. But if I take moment about O, then Rx and Ry will become 0. Moment of 100 Newton I can calculate. So I can find alpha. But you will say, sir, O, can we take moment about O? Yes, we can. Because O is not moving, right? O is not in motion. Don't say that it is not fixed, sir. It is hinged. See, that's a technical term. Fixed means there will be couple hinge. That's a technical term. If you consider from the motion point of view, then point O is fixed, na? It is not going anywhere. So we can take moment about point O. I can write it like this. Now what will be the moment of inertia about point O? ml square by 3, because point O is the end of the rod. And if you take moment of inertia about the end, ml square by 3. If you take moment of inertia about G, ml square by 12. So take moment about point O, beta. It will be 100 into this distance. Length is 4 meter. So this distance will be half. ml square by 3. M is 10. Length is 4. So from here you will get the value of alpha. Okay. So I am getting 3.75 radian per second square. Yes. The first statement is correct, right? Angular acceleration of the rod is 3.75 radian per second square. Okay. Second, angular acceleration of the rod is constant. Is this correct? Angular acceleration will change with respect to time or will remain constant with respect to time? Most of you will say constant, sir, because there is no time, it's not a function of time, so alpha is constant. But you are forgetting something. See, right now you have calculated the value of alpha at this particular instant. What if the instant changes? Means, what if the rod becomes like this? What if the rod becomes like this? In this case, will the value of alpha remain same? Let's see. Let's see. So this is O, this is G. Okay. This is the weight, this is Rx, this is Ry. Now this is a very interesting concept, okay? Very, very interesting concept. Understand. If I take moment about point O, what I will get? Same thing. Moment of Rx and Ry will be gone. Now the moment of 100 will not be L by 2. It will be L by 2 cos alpha, right? It will be L by 2. This is L by 2. This is L by 2. Cos alpha means 2 cos alpha, and it will be 10 into 4 square by 3. I will remain same. So from here, okay, let me consider this angle theta, otherwise we will get confused. Cos theta. So now alpha will be 3.75 cos theta. So what does this mean? It means that alpha is a function of theta. It will not remain constant. Remember this, whenever you have a question of rod, whenever you have a question like this, there is a question of rod, alpha is never constant. Alpha is a function of theta. So if theta changes, alpha also changes. Means if theta is 0 degree, alpha will be different. If theta is 30 degree, alpha will be different. If theta is 90 degree, alpha will be different. So beta, here alpha is not constant. So this second statement is incorrect. Now they are asking you to find the horizontal and vertical reaction. So we can apply summation of Ft and summation of Fn. If we apply summation of Ft, it will be equal to mat. Okay. So summation of Ft will be what? In the direction of At, net force will be 100 minus Ry. M is 10 kg. At will be alpha into R. Alpha is 3.75 and R is what? R is the distance of G from center of rotation. So 2 meter. Okay. At is alpha into R. So from here you will get the value of Ry. What is Ry? 100 minus 10 into 2 into 3.75. 25 Newton. I am getting positive answer, means my direction is correct. In order to find Rx, you will apply summation of summation of Fn equals to MAN. AN is what? Omega square into R. Okay. Now what is summation of Fn? Minus of Rx. I am considering Rx in this direction, opposite to AN. So minus of Rx equal to 10 into omega is 5. They have given. R is 2. So from here Rx will be negative 500 Newton. Now why negative sign? Because I have assumed Rx wrong. My Rx should be, the actual Rx should be in this direction. Okay. So this is, Rx is 500 Newton. This is correct. Ry is 25 Newton. This is wrong. The correct answers are A and C. Okay. Now these type of problems where there is a rod which is hinged at some point, it's very common question. Okay. So this question is your assignment question. I want you to solve this question on your own. This is your assignment question. And in the next class, we will see some more problems using this D'Alembert's method. Okay. So thank you so much. I will see you in the next class. Till then, bye-bye. Take care. Good night.